Okay, today we are looking at the idea of basic angle facts. Specifically, we are looking at the idea of complementary angles, supplementary angles, angles on a point, and then finally we're going to look at the idea of vertically opposite angles. Let's start right away with complementary angles. If two angles are complementary, or if two or more angles are complementary, that means that these are angles that sum to 90 degrees. So complementary, they sum to 90, they form a right angle. Not a big deal. So if I just very quickly insert an angle here, and I tell you that this is 30 degrees, then the other angle, this other angle here, would have to be 60 degrees. That's pretty basic. I don't think that's too difficult. Obviously, we can make that a little bit more challenging if we add just a little bit of algebra to it. Sorry, I'm having a bit of an issue with my eraser here. And yes, that is sweet. There we go. All right, so let's look at maybe a more complicated version. So if I draw an angle like that, and I tell you that this is 40 degrees, and this is 3x minus 8 degrees, then what we need to be able to do is to set up that algebraic equation and solve. So when I do that, this would turn into 40 degrees plus 3x minus 8 has got to be equal to 90. And now we're just going to use our inverse operation rules, and we're going to figure out what that is. So in effect, I've got 3x plus 32, because 40 minus 8 is 32, is 90. So 3x's is 90 minus 32, which is 58. And then x equals 58 over 3, which we can simplify, but I'm happy just to leave it as a fraction. Okay, that's complementary angles. They add to 90. Supplementary angles. If complementary add to 90, supplementary add to 180 degrees. So angles on a line, this measure here, if I say this is an angle, is always going to be 180 degrees. I don't know why I drew my 8 like that. Who knows? So again, what this allows us to do is for us to be able to do perhaps more complicated problems, where if I tell you that this A, B, C, and I'm going to put D over here, if I tell you that the measure of angle ABC is equal to, let's say, 45 degrees, and the measure of angle ABD is the same as, let's do 5x minus 15. Okay. Then again, what we can do is we can set up the algebraic equation, and then we can solve for whatever x has to be. So what that would look like is we would do 45 plus 5x minus 15 equals 180, and then we set that up and solve. Again, we're going to use inverse operations. I'm going to gather some terms here. I get 5x plus 30, because 45 minus 15 is 30, still equal to $1.80, so 5x equals 150, x has got to be 30. So there, we're using the angle rules. Supplementary is 180, and we're able to solve. Real quick here, the way that I remember complementary versus supplementary, complementary starts with a C. That's earlier in the alphabet than supplementary that starts with an S. So complementary, C, goes with the lower degree of 90 degrees. I know that makes perfect sense. Can I say I'm a genius? Next up, angles on a point. If I look at all of these angles, what will happen is they're going to sum to 360 degrees. So you can see right away how we would apply this. I don't think there's anything that we need to practice here. 360 degrees is what a circle has in it. If it's an angles on a point, then all of these angles added together would end up being 360 degrees total. Okay? Easy enough. That you can practice. Now, my favorite angle theorem is the vertically opposite ones. I'm going to show you this by saying that if this is 120 degrees, we're going to use the angles on a straight line, the supplementary angle idea. And real quick, what is the measure of that angle? Thank you, it's 60. Good work. So if that angle is 60 degrees, and I'm using this angles on, or supplementary angles again, what does this angle have to be? Well, if that's 60 and it's 180 total, that's right from the back there, that's got to be 120. Let's keep going all the way around this thing, all the angles on a point. Well, we know that that's got to be 360. We could also use complementary or supplementary angles. Just told you how I remembered it, and now I keep saying it wrong. If we go with supplementary angles, this has got to be 60 degrees as well. Notice what's happening here. If we have angles, two lines that intersect, vertically opposite angles, the ones that are across from the intersection, will always be exactly the same. Their measures will be the same. So what this tells us is vertically opposite angles are congruent. I can spell the word congruent, and we use the symbol that to show congruent. Congruent just means geometrically equal to. So congruence is something we're going to spend a lot of time with. It just means geometrically equal to. Angles are equal if they have the same measure. So that is where we're going. Obviously, you could imagine algebraic implications here. So those algebraic implications will allow us to be able to make this work. All right. Thank you.